I'm CK. Today we've got another kit from Whadda. This is their clap on-off switch, so probably got a microphone and a relay or maybe just a transistor setup. We'll see. Looks like it might be useful after we're done too. And I hope you enjoy the video. Here's the box. Typical Velleman Whadda box, clap on-off switch, home applications. Yeah, it does look like it's got a relay on it. Soldering kit, level 2. Ideal for disabled or elderly people. And since I'm elderly, I guess it's for me. Good immunity against surrounding noises, good. 1 or 2 clap mode. 24 volt DC with 3 amp relay power rating. Wow, that's 3 amp relay, that's pretty good. 12 volt 150 milliamp power supply, DC adapter socket, so it doesn't come with the power supply. Here's the bits, here's the QR code for the build guide. I think we need to slide the outer wrap off. Let's see if it's, I don't see it affixed anywhere. I don't see a little dot of adhesive or whatever, but I can't slide it off. There it goes. And here we are. Oh, we do have a piece of paper in here. Let's look at the piece. Oh, first we'll get the box ready for recycling. And we'll look at the paper. Typical Whadda Velleman paper. Diodes, caps, sockets, switch, transistors, voltage regulator, LED, electrolytics, connections, power jack, microphone, and the relay, and one IC. It's LM324 or equivalent. I believe that's an op amp, but I'm not certain. And PIC 12C508A. And I don't know what that is. I'll look that up. Then we've got tabs for the output, for the input, I believe. And then here we have a sample of how to wire it up. And we've got a schematic. Schematic's pretty tiny, but that's okay. Yeah, this is the first IC. This is the 324, as you may be able to tell. It's an op amp. But the other one, this one, I don't know what it is. So here's the board. Not through-hole plated, just regular single-sided copper. Easy to follow the traces, of course. None of the values are on the board, so we do need the piece of paper. Switch 1 is 1 clap, 2 clap. This switch is output relay is either pulse, like a trigger signal, or a toggle, which I believe will hold it engaged. Now let's look at the bits and pieces in the bag, if I can get the bag open like a regular human. Yay, I did! Nothing else in the bag. Whole raft of transistors and the diodes on this end, and typically when Velleman does this, these are usually sorted and they're in the typical positioning, installation sequence, but that doesn't really matter. I guess it does because it's listed up there, never mind. Here's a piece of foam that I assume is where the ICs were put in when it shipped, but they didn't stay in during shipment. That's the 324. This is must be a microcontroller, the 12F508. And the reason why I say that is, besides the fact that I don't know the part number, there's a highlighter mark on it, which indicates to me that it has been programmed. Here's the relay. That's why it can take 3 amps. Wow. I'm sorry, this The box said 3 amps. This says 15 amps, 125 volts AC. 10 amps, 240 volts. 10 amps, 28 volt DC, and 10 amps, 28 volt DC. That's the same. This can take 15 amps throughput? Well, that's pretty good. I don't know if the traces on the board can. So there's the common, normally open, normally closed, common 2. Well, I guess so. Those are some pretty beefy traces. Some other things, a little LED, a little microphone with a tab, so you can get it in there with the polarity right without having to be too worried about it. And some random capacitors. So we'll get the soldering iron heated up, and I'll look up that part number, and we'll put this thing together. Let's put this little guy together. First, we're going to do the resistors, as is typical and as the build guide recommends or describes. So we'll start with the 10Ks, and there should be, what, 4 of them? And there they are. Now I'm going to put them on the meter just to see. They're shown as gold band tolerance, so they should be pretty dead on to 10K, and this is showing 9.9. That's fine. And that's going to be R1 through R4, so we'll put 1 on live. You can find, I'm having trouble figuring out which side of the board is up. I always like to have an up orientation. So there's R2. Oh, R1's all the way over here. So we can leave about 1.5 millimeters on each end of the resistor lead away from the body. I just dropped my solder. I keep doing that. Let's see how the board takes solder. About what you'd expect for non-through hole, old school. Now this, it just did what you're going to want to watch for here. Let me zoom in as much as I can here and make sure this focuses. Yeah, it's focused. So if you look here, I put the solder on it and it made a donut. It went around the plating but didn't engage the resistor lead, or engaged it only slightly. And you're going to want to watch for that. So when you see that, you'll just want to add a little more solder, let it heat soak a teeny bit, and then it'll be completely filled in. Only thing to watch out for. So nothing much more to talk about with resistors. So I will be speeding up playback and muting the commentary, which gives you a chance to enjoy resistor time. And that's resistor time for this kit. I'm still zoomed in because I want to touch on 2 things. One is resistor R18 is a 0 ohm resistor, single black band, so it's providing no resistance. Some designers use this instead of a jumper wire, and what he's jumping is he's jumping across this trace here to take, it looks like, let me see what he's doing here. Looks like he's taking the ground plane into here, because this big ground plane is separated from the interior here by these gaps. So he's using that to jump. And one other thing, I'm trying to remember where it is. Here, these two leads have a joint solder pad. So the solder pad is connected, so don't worry if you bridge those, because you're supposed to. Now I'm going to back off a little bit. Give us a little breathing space, even though you guys, again, you need to tell me if I'm too close or too far away. Let's see, we're going to do... the diodes, which are pretty much the same, but I think they've got it out of order. Because we've got 4 4148s, or 4,000, wait a minute, no, I don't know what, oh, I see, this is a Zener, okay, this is, what is this? This is a 4V7. Let me double check that. And that goes in ZD1, and the black band on the diode matches with the white stripe on the printing on the circuit board. Now we've got our 4007s and our 4148s. 4007, which is typically polarity protection for power coming in. That's why when I'm putting it in, I always look where is the power connector, because it's probably close to there, and that's absolutely as typical correct. And there's usually, as you can see, there's a capacitor right next to it too. I bent the leads in a little too much, so I got to give it a little encouragement to go through. And I didn't encourage it well enough. I'll just press on it. There we go. Now the rest of the regular little diodes, switching diodes. Same thing, make sure the black line is on the white line, the heavy white line. Next is capacitors. And we're going to do the little disc caps, the 100 nanofarad, 3N3, and the 27 nanofarad. So there's the 27. These are those white on, I mean gray on white caps that I can always barely read. How many of them are there? I think these are both the 104s. I got to get a different magnifier in here. Yep, those are my 104s. Now when you're working with these, typically I don't try and pull them out of this tape carrier. I just cut them off, because if you try and pull them out, you're just going to get frustrated, probably bend some leads. It's designed for a machine to take them apart, not for human beings. So just clip them free. And then these go in C2 to C7. I'll leave those leads uncut for a minute while I get these other two in. So we've got the 3 nano 3, which goes in C8. and the 27 nano, which goes in C9. I just saw it. There it is. And while we're here, it's time to put the socket on, IC socket on. I'll solder those other things when I do the IC socket. There's a notch on the board, printed on the board, and there's a notch on the socket. Just match them up and get the holes to line up. Oh gosh, I didn't even notice that. We got some bent pins. And as you can see, I'm using my needle nose pliers to get them all parallel with each other. I don't want to bend just one lead, because then it might be out of position. Now that's staying in pretty well, but I'll just show you what I typically do. As you can sense, I'm resting the socket on my pinky finger and doing one leg. Now I'm going to look and see if it's all down. Yep, it's all down, so I can solder all these connections. So that's all of that. Now we'll do the transistors. We've got 2 transistors and 1 voltage regulator. Now transistors, most transistors and voltage regulators look very similar. They're the same. These are transistors, these are voltage regulators. They look the same, don't they? So you have to pay some good attention to make sure you're getting the right thing. These are the 547 transistors. Little switches. And they go in T1 and T2, and let's see, middle leg goes backwards a little bit, or to the rear of the flat side. And you match the flat side on the transistor to the flat side printed on the circuit board, or else it won't work worth a darn. Now interestingly, the voltage regulators, which have the same type of pins and the same flat side, they don't spread one pin backwards. Never understood that. And again, these are 78 LO5s. Are they LO5s? Yeah, they're LO5s. Oh, one, that's why I was reading it funny. This is an LO8. This is an 8-volt voltage regulator. The other one is a 5-volt voltage regulator. So again, be careful that you get the, and I'm just double checking, be careful that you get the 8 volt in the 8 volt location VR2 and the 5 volt in VR1, voltage regulator 1, or else things will not work not work as well as you might hope. Probably will work a little bit, and it'll be kind of confusing because you're wondering why it's only working half good instead of all good. Now we'll put the LEDs on the board, and they don't have a plus sign, but they do have a shaded and flat side. So the short lead goes in the shaded flat side, because that's the cathode or negative side. One of these indicates a clap, the other one tells you when the relay is engaged, I sense. So I'm going to do one leg of each, and then, because that didn't make them flat on the board, I'm going to hold it, push on it with my Index finger, reheat that solder ball, and you probably heard it click as it hit the board, the flat on the board. I'll try and be quiet this time so you can hear it. And of course that time it didn't click. But that's what you want to do. And I didn't even get it straight that way. Huh. Heat it up again. There we go. Now we'll put the electrolytic cap on board. And the long lead on that is positive, and there's a plus sign on the board. And this is the 470 cap, and this is a vented cap. It's class Y. That's pretty good. That's a good safety cap. Now we should have one more, and we do. And that one goes over here, and interestingly, it's got a plus sign there. That's really close to that IC socket. I'm not going to solder that. I will solder that because we're going to do some mechanical stuff in a second. Now we're going to do our connections. Connection blocks. Where is... Oh, there it is. It's only one. Oh, there should be... Oh, there's only one. Actually, that's not true. There should be... Got that. Where's SK2? Oh, SK2 may be the pins. Yeah, the SK2 is the pins. And the power jack. That is keyed. The connectors can only go in one way unless you really do something very, very forceful, which you don't want to do. And same as the socket, I'm going to solder one leg and look, and as you can see, it's all kind of raised up. So I'm just going to put my index finger on it, reheat that solder, let the solder cool, and there we go. Now it's flat. And you can see the two pins here. I'm going to put them on now, even though they put this in a later step, but I'm going to put them in now. And I'm not going to press my finger on that one, because it's stainless steel and will transmit heat very effectively to my finger. So I just put a piece of foam there to keep those in place. So this is two different ways of powering this. Let me take that foam back off. Two different ways of powering it. You can plug in 12 volt DC, 120 milliamps, or, and it's center positive, or you can use these two posts and run a wire off there to power it, plus minus there. As you can probably see back here, though the traces from the two pins go to the same place as the traces for the power supply, so it's just sensing. Use either one of them. Go ahead, we don't mind. Oh, I forgot one socket. I was going so fast I didn't realize there were... This is the little mini microprocessor socket. Yep, and that's got a bent pin too. Now we're going to put the microphone on. And again, it's got the little tab here, and there's a little tab slot on the circuit board, so you don't have to worry about getting the orientation right. The package is orienting it for you. And now the relay. Actually, oh, I didn't put the switches on. Silly me. Switches are going to be the same as anything else, but again in this case, primarily because we've got some stuff already on, Just going to set it in there, put a piece of foam on top of my solder pad, and that'll keep the switches in place while I solder them. Now we'll do the relay. And the pins are in an offset type of configuration, so again it is relatively easy to get that right. Now it's high enough, it's tall enough that I have to push down with my finger to keep the board level. Now with that one pin done, I can let it sag to the side because it's not going anywhere. And you can see the traces going to this output block. So when the relay, obviously when the relay closes, not obviously, when the relay closes, when you energize it, there's a normally open and a normally closed position, and when you energize it, it either breaks this one or closes this one. This is the common, say that's the negative voltage, and this will be the positive active when the relay is on or when the relay is off, which gives you flexibility. It's a nice thing to put in. And now we will put our ICs on. I'm bending the legs in just a little bit against the side of my workbench because they usually come splayed out a little bit too far. It's relatively easy to see which goes where because they've got significantly different number of legs, and I just put that in backwards. I was looking at the dot instead of the notch. I thought they'd mark this with a dot, like they do sometimes instead of a notch, but they didn't. They marked it with a notch, and I didn't pay attention to it. But caught it, and we're all good. And here's the little microcontroller. And I've got the notch right this time. And that, my droogs, is that. Now we just need to get a power supply and something to operate with, and we will check this little fella out. So I've got it set up. I give it a little try. I'm not sure it's working quite correctly, but it does actually work. I've got my little 12 volt DC going in to power it. You can see this light is lighting up, showing there's some sound input. Then I've got a power supply connected to this little fan motor. So I've got it in one clap mode and toggle, and when I clap, it doesn't do anything. If I go to 2 clap mode and clap, it didn't do anything. Put it in there. It was just working. There. Goes on, and you can see the relay signal is lit, and the fan is on, and that is in, it's supposed to be in pulse. Oh, I see, toggle mode is 0. Okay, toggle mode is the switch this way. Now when I clap again, clap again, maybe double clap, It's not going off. Let me go put the switch in single clap mode. Okay, I'm going to flip this. See, it's just continued. The relay is closed, so it's pumping out power. Yeah, it doesn't seem to work very well. I mean, obviously, I can get it to come on. I'm going to unplug this, and then everything will go off again. I'm going to plug it back in, and we'll tap the mic twice, or once. Go into toggle mode again. And there, it came on just for a second. Go back over here. And there it came on for just a pulse. That would be the pulse mode. Now we'll go back into toggle mode, which should bring it on and keep it on. And there it goes. Okay. So now it's on again. Now maybe theoretically I can turn it off. And there it goes. Okay, for some, I don't know, it's a little, I'm sorry, let me try and be articulate. I would love to have a sensitivity rheostat or potentiometer in there. There it goes on. And there it goes off. So it works. Takes a loud noise. So that's it. As you saw, it's a pretty simple or interesting circuit. I mean, obviously, there's intelligence in here in this chip to record double claps and things like that. So it could be a fun little kit. You may want to set it up to turn something on and off in your room or whatever. That's a good relay too. I may just scavenge that relay from this kit. Now it didn't go on again. Again, it's a little funky on whether it picks up a clap or not. And quite frankly, my hands are getting sore. There it goes. It had to be a good loud clap. And my power supply over here, which is driving this, the display went out. That's interesting. So that's what it does. It's a fine little unit, and I hope you enjoyed the video.